All right. Ice, ice, icicle. Particle. Test, test, testing. All right, it's working. I can see everyone can hear me. Cool. So this is the session about the Microsoft Bot Framework. And at the end, I'm going to show a little bit more about the Azure bot itself, the code behind it, and etc. And if this wasn't the session that you wanted to come to, then now you're going to listen and learn about the bot framework, I guess. If you were in Bill's session just before, then that was a pretty great introduction into the basics of the bot framework. I'm going to cover a little bit about it here, but then later on go into code, show you a couple of examples, and also show you some bot examples as well. A little bit of a repeat from the keynote yesterday as well, and then some other bots, right? Cool. So bots aren't really new. Why are they all of a sudden becoming so popular, right? And there's quite a few things that you can think of, and you probably, if you think about it, there's a convergence of technologies. Both the first two lines there are sort of aligned, where there's been a lot of cloud computing power that has shown up in the past few years that allows machine learning to be better over time and get a lot better in the past few years. And it allows also the powerful bots to be built on top of those. Also, the ubiquity of communications channels. You know, up until a few years ago, if you wanted to chat to someone, you would have to go home, get to a computer, and start typing messages to chat with someone. But now everyone has a computer in their pockets and multiple ways of text message each other, right? So this communications channels have become very, very popular. And even that big boom of apps that we had in app stores for mobile applications are slowing a little. And even if you look at the top ones, excluding gaming, they're all messaging apps as well. So Facebook Messenger, WhatsApp, and all of those. So that's why bots have started becoming more popular again, is because they are ubiquitous. There's a lot of text messaging, and people just like to message. Most people nowadays, they don't think about calling someone. They just send a little message, and that's it. And some things to keep in mind as you are thinking about building bots. The first one is they can be very, very simple tasks, automations. You don't have to make them too complex. So it can be something that just helps you book an appointment at a hairdresser, or some, like Bill mentioned, set an alarm, or even to reset your password. If you're building a bot that is internal for your company, you say, my password is not working, I want to reset it, and it'll then email you and say an email was sent, right? So you can write very, very simple bots, so you don't have to start thinking about it as being a super complex thing. Another thing is that they don't have to be only text. Most of the interfaces now, Skype, Facebook Messenger, they all support interfaces that are buttons or hero cards or images. So you can make your bot pretty rich without, and then this also helps it guide your user to what the bot can actually do. So the bot can be pretty simple to say, all I can do is find a hotel for you. Don't try to tell me the story of your life. Just click the button and tell me what it is, and I'm done. And like Bill said, you don't try to make your bot pass the Turing test. That's Turing there. So narrow the scope, use a little bit of regular expressions where it makes sense, or some language understanding with the Lewis model, but you don't need to go overboard and pretend like your bot is a human behind the scenes. So basically, like I said at the keynote yesterday, bots are just like applications, but they provide a more natural interface to your users. They provide also some faster access to what the user wants to do, and it enables mobile access to things where you might not have that kind of access through other interfaces. So to get into it a little bit deeper, there's another view of the bot framework and where your bot sits when you're writing an application to use the Microsoft Bot framework. So the bot connector here in the middle, it will handle the message input and output from multiple conversation canvases or channels is what we call them. It'll handle the logic, and also it'll keep track of the state for you if you need to have a state for per user or per conversation or per user channel. But your bot code can be anywhere. It can be on Azure, hopefully, but you can host it anywhere. Just like Bill mentioned, it's just a web API that you can write in .NET or in web in Node. And of course, your bot will have to do something, and most of the time it's going to talk to your backend. So that's where, from your bot, the user sends a message through the bot framework. It comes through the bot builder SDKs into your bot itself. Then you figure out, oh, this is what I need to do. I understand what the customer wants me to do, or the user. I'll go to my services, like figure out if that time is not already taken, and then book the appointment for it and send the message back. And sometimes you might use a few of the cognitive services or the intelligence services as part of it, but you don't necessarily have to. But of course, if you do, then we do have the Microsoft Cognitive Services. There's quite a long list of them, and not all of them apply to text, but you can even add speech recognition to it. So there's a couple of them that are very popular for bots, like the language understanding, and also there's some where you have a specific set of words and things that are too specific that a regular language understanding won't pick up, and you can train it with your specific text as well. So there's speech there, and there's that for language and text. So you can enhance your bots as needed with these. So what does the developer portal looks like? I showed it yesterday, but just to remind you, you create an entry for your bot on just botframework.com. You go in there, sign in with your Microsoft account, create an entry for your bot, and that will give you a Microsoft App ID, and you can also test it from there, but then you can also enable channels. So this, I had just created one, and the only channels, I think it enables Skype by default as well. But the direct line is one that it doesn't have an interface. It's for you to get straight into the bot and back. And the web chat, those are enabled by default. But then all the other ones, you can just configure them with your Skype or Facebook or whatever credentials, and it'll have that set up for you. So once you have this, then in your bot itself, when you create the code for your bot in your web API, you just need to put in that Microsoft App ID for the bot, and a key, one of the keys that it will give you, and then your bot is ready for you to test. You can start from just testing it locally, and I'll show you that later. Or you can also deploy it to Azure or somewhere that's not running locally on your application, and then run the tests from there as well, and then do remote debugging if needed. So it's your choice of how far you want to go with the testing before you deploy your bot somewhere and enable it for everyone. And of course, by default, it says publish there on those two, because I haven't published it to everyone yet. So if you have the specific links that it gives you here, you can test it, but it won't be available for just anyone. The other thing is the Bot Builder SDK. Like I said, we have an SDK for it's all behind REST API, so if you really need to, you can write it in any language. But the Bot Builder SDK is both in .NET and in Node, and it's pretty straightforward to add those to your application and then get started. And then this is what gives you the methods and access into what the Bot Builder will expose to you, so the state and the dialogues and all of that. So dialogues, and then you can create multiple dialogues and build a conversation with your user around all of those dialogues as well. So just to go into dialogues a little bit more, they're reusable, so you define your dialogue in code. Usually I create a class for each dialogue that I have in .NET, and You can then enable conversations. And finally, the state for the dialogues itself is maintained by the bot connector. And you can have it per user. So I know that this user is this person, so I'll keep the state for that user. Or it can be just for that session. And I'll show an example later where I set the city to be Seattle and my name as Thiago. And that conversation, I'm keeping that state. And then finally, it can be a combination of those two. And that's what I do with the Azure bot, what we do with the Azure bot, where this user, well, no, the Azure bot is just the user, where this user logged into Azure once, and this is the token that we have for Azure to interact with Azure. And we'll just keep that token for that user in the bot connector framework, so that next time the person comes in and signs into Skype and starts talking to the bot, it knows who the user is and that the user is already signed in. There's quite a few different types of dialogues. So you can build a dialogue with all of the different methods that it can handle. But there's a few ones that are so common that the bot framework also has that built in for you, especially in .NET. There's built-in prompts there for you to just confirm things, yes, no, enter a string, enter a number, or give the user multiple choices and make the user reply to me. So you don't have to code all of those questions and answers in. You just say, bot framework, talk to the user for me and get a string back or get a number back. And it'll go and do that conversation for you. Once it's done, it'll return to the main conversation part of your code. There's also language understanding through the Lewis model. So they have a base class that you can use for Lewis-based ones. So the stuff that Bill showed before, where you have an intent in the language understanding, and if it identifies that as the intent, then it will send you into the part of your code that matches that intent. I'll show you that a little bit later as well. And then there's this idea of filling out a form. So if you think of an application with a form where you have to enter your whole address, you can define that in a class saying, you need to fill out all of these things for me. Bot framework, go and ask the user to enter all of these values for me, so I don't have to make that whole conversation happen myself. The bot framework will take care of that for me. Just like the profile there. So how do you get started? Let me see, I'll have sign in here. Okay, so I'll just switch over here. And if you go to, let me zoom in a little. To this location, let me see. So on GitHub, there's these samples. If you go to github.com/Microsoft/botbuilder-samples, it will have quite a lot of different samples in there that you can use. And I'd recommend, if you haven't built anything with the bot framework before, I'd recommend just starting with one of these samples and then modifying it to what you're trying to build. So let me, so I'll go into Node first. And I'll go to core state. And I'll just start Visual Studio Code here. And that opens up that example there. If I go to package.json, you see that the dependencies that it has is just on two things, the bot builder package and Restify to make it into a web API, right? So it's very, very straightforward. The only two things that you need for a simple bot is the bot builder SDK and NuGet package and Restify as well. And then here on the application itself, what we have is we start by creating a process that starts listening in on that port 3978. And it listens on /API/messages. And then it defines a few dialogues by using the bot framework. So you can see here an entry point dialog, one for search, and then other that matches specific keywords. So very, very straightforward ways to do things. So for example, if I put a breakpoint here on after it asks for the username, you see that when it first starts, it says, oh, do I have a username in this session data? And if it doesn't, then it'll forward me to the ask username one and then come back here to continue. So that's how you do the back and forth between the dialogue that your bot's going to have with your users. So I'll just go into debug here, launch this app. And then on Windows, there's this really handy bot framework emulator. For Mac and Linux, it's more of a command line based, but you can still test it out on those too. And I think that's the right port. Just want to make sure. But if I then start talking, ooh, maybe not. 3. Let me start this up again. Oh, I'm not connected. That's why. Do you have a hardwire Ethernet? Sorry, let me just get connected first. Any of these? Yep. Okay, that'll be just a couple of secs for it to connect. And as the dialogues go through, it will back and forth between these, and that's how the conversation itself happens. And it'll just keep getting, conversation data. So there's two things that it does. It's my name and then the key for the city here. So it's getting a city and then my name, and then it runs a search for me on Bing for what that does. So it's a very simple example of a bot. We have that same sample here that is in .NET. So it's exactly the same state one, but it's in .NET, and you see that it's basically an ASP.NET Web API application. So it has a controller here for the messages, and that controller, all it does is as soon as a message comes via post, it will forward it to this dialog. So we created a dialog that inherits from the iDialog, or implements the iDialog interface here, and then it will just get into start async and start the conversation there. So in .NET, instead of doing the back and forth between, you can still do forwarding and returning, but in this case here, we are just awaiting on more messages from the user once it gets started. So let me try this again. I think now I'm connected. And before we get started, tell me your name. I'll say Thiago. And that'll break point there. And you can see it's now then saving my name into that user data. So that's what the state of the bot framework does for you, right? It's keeping that conversation data for you. So next time, as I continue to talk to the bot, I can bring back that state and make decisions. So if you are building something that the bot needs to do, but there's a few things that you need to know, this is a good way to keep track of that and then execute it and based on all of those. And then likewise, from here, from the state bot, say if I put a breakpoint here, and start it up. Let's see. That goes to 3979. Oh, it's not attaching. That's okay. But from the .NET side, it's very much the same. But in here, you do the main difference that I see is that once you do a prompt dialog or you run a dialog, you can pass in what does it call after it's done. So it goes into resume after prompt. So this here, it's prompting, and this is one of those examples, like I mentioned, where you want the user to enter in a text of sorts. In this case, it's just asking for the person's username. So we can use a baked-in type of dialog that the bot framework gives you called prompt dialog, and then asks for that. And once it's done, it's going to go into resume after prompt. And then resume after prompt is where it continues, puts the username into the context, which is that context for this conversation, and then goes back to waiting for messages from the user. So it's pretty straightforward way to go back and forth in this dialogue and go to an end-to-end conversation with the user. So that's a pretty quick getting started. I just wanted to show you where to go and see the samples, and take one of those, try it out from either just doing Node app.js or just start it up from Visual Studio Code, or in .NET just run it from Visual Studio itself, and then use the emulator, the bot framework emulator to talk to the bot and understand how they've built the samples. And they seem to have done it pretty well, so that there's samples both from .NET and Node for exactly the same functionality. So there's anything there that does hero cards, that does search, that goes into a document DB database, and etc. So I wanted to show you a few examples of bots that I like. This Hipmunk is pretty similar to the Skyscanner that we saw yesterday, but it's one of the ones that I think that makes more sense to be backed by the Lewis Understanding Cognitive Service API. So let me get into Skype here. Let me get out of there. If I go to Skype, let me see. I want a hotel in Miami from November 15 to November 30. And the interesting thing here is that it identifies as the intent as find a hotel. There's no flights involved or anything, so it's find a hotel. And it finds two entities that are dates. One is the from date and the to date. So in Lewis, the language understanding model, you can say, I need two entities for this intent, and they're both meant to be dates. So it understands that and then goes back to the Hipmunk code and finds the best options for hotels for me. And you can see you can be pretty sassy. You can say, I'm ecstatic about these hotels for you. And this is a way that your bot can create rapport with the user as well. So this is one where it does make sense. So I know we talked about, don't try to go nuts on the cognitive services, but where it makes sense, it does make sense. And then from here, you can then see the hotel deals, and it'll take you into their website to finalize the booking of the hotel. Right? So that's a pretty good one. The other one is one that we built in our team. It was Ryan from our team that he worked on this for an event that we have in Seattle called Bumbershoot. And it's one of those events that goes for 3-4 days, and it has music, it has all sorts of different presentations, and people could just go onto Facebook Messenger and ask questions about, what rock shows are going to happen on Friday afternoon, or where can I find the bathroom here in the event. So they promoted this bot for people that were attending to the event. And the cool thing is it doesn't have Lewis behind it. It just uses Azure Search on top of the DocumentDB database, the NoSQL database. So they entered all the details about the event and the acts and the dates and et cetera into this NoSQL database, the DocumentDB, and put Azure Search on top to help them identify what the person was looking for. And then for some specific keywords, they also have regex on top of it. And that's all that they needed for this bot to work. So let me see here. I'll go into my bot framework demos here. They've already taken it down, so I asked Ryan to just get given permission. So if I type something like Rock on Friday, that'll go off and find all of the rock events that are happening on Friday, right? And it basically identifies the two keywords, Rock and Friday, for the date, and goes off and does that. If I just start chatting with it, then it says, oh, what would you like to do? And if I type in something that it's not one of the keywords that it's looking for, like pony, it basically does an Azure search, a full text search against all that is in that database and finds anything from the event that has pony. And luckily, as if I had prepared for this before, there's a pony time that presented at 3 p.m. on Saturday. So this is pretty cool. Another one that I really like is I want beer. And then it identifies beer as one of the keywords, and then it just gives me a map of the event where all the bars are at the event there, those ones in red. So it's a pretty cool example of a bot that doesn't have language understanding behind it, but it uses Azure Search or full text search. It doesn't have to be Azure Search, a NoSQL database behind it, and regex for some specific keywords. Cool. Okay. And the last one that I want to show before I go into the specifics of the Azure bot is Your Face bot. Does anyone know that bot? All right. So Your Face is a very grumpy bot. But it basically look at that guy. And it describes, it uses a few of the cognitive services APIs to describe your face, basically. And there's quite a lot of awesome examples of real-world scenarios where cognitive services are being used for. Just the other day, we launched the details about how Uber is using the face recognition API with the drivers to make sure that the driver that is starting the car is the actual person that is in the profile, right? But this here is just to show a few of the APIs that you can call and combine behind the scenes for a bot. So if I start chatting with it, hey, you see that already it's already pretty grumpy. It's like don't try to chat with it. Come on, right? So I'll finally upload an image here. I think I have my profile photo there. And then what it does is it goes off to some of the face recognition APIs, identifies things about my face and said, you've got the sad first sproutings of a beard, you're wearing sunglasses which may or not be called shades, you look happy inexplicably. So it's actually quite accurate. But what it does is it goes to cognitive services, finds out about features of that face, if it's a man or a woman, has a beard or not, wearing sunglasses or not, and then describes it. The other thing you can do is, if you do upload someone like that, it also recognizes that that is a celebrity and says, are you Sonny B. Williams? And then finally, if you try to cheat, of course, that was the first thing I tried, is to put a dog wearing a suit. It goes and describes what's in the photo. So that's really cool. And how it does it is once you see it from the Cognitive Services APIs, it basically just combines a few of those. So if I go into computer vision here, this is the API that will analyze and then describe the image for you. And if I scroll down, it has a recognize celebrities section as well. So if I upload that same photo of the educated dog, it basically says, let me zoom in here, a dog wearing a suit and tie. So you can see how for that, the code behind of that bot, it basically went into this API. Well, it went into the face recognition one, couldn't find any human faces, and then put it in through this one that will explain whatever is in the photo, and just place, put something funny around what the description of that photo is. But of course, if I go to the face one and upload myself, let me see profile here. You see it returns a JSON there with a lot of details of where my nose and eyes are. But at the end, it has the age, and that's exactly the age that the bot said I was. Thank you, because that's way younger. Male, a little bit of facial hair, and then I'm wearing sunglasses. And based on these, it just has a list of things that it can say that are pretty mean about your face. So that's another example of combining a few APIs behind the bot framework to write a bot, right? And then finally, we have the Azure bot. So what we started with was we had we had one dialogue only in Lewis that tried to identify all of the intents of what someone was trying to do. So if you wanted to do list VMs, it would go into this one dialogue. If you wanted to change subscriptions, it would go to the same place and try to identify that intent. But recently what we've done is we've split it up into multiple dialogues. So now it goes into this root dialogue that manages subscriptions, logging in and out of Azure, and logging and selecting which subscription you want to work with. It forwards to this auth dialog that does the auth for us, and that's a NuGet package from Matt Veloso for that. But then if there's any other commands that it can't identify, then we loop through a bunch of other dialogues and say, can you handle this based on some keywords? So for example, if you say list VMs, it'll loop through each one of those other dialogues, say, can you understand what list VMs is? And then one of them, the first one that replies with yes, then it goes into that, forwards the conversation into that other dialogue that then takes care of it. And once that dialogue is done, it says done, and it goes back to the root, and then it all starts again. So that's how we've implemented the Azure bot itself. So let's have a look at the code behind it. So here I have the code for the Azure bot. You see, the main one here is the web API. That's the front end for it and handles that first controller there for the web API. But then we have a few other like common and etc. But there's one for automation, one for resource groups, and one for virtual machines. And then each one of these will have a dialogue. So in the main one here, we have this root dialogue. In the root dialog, it has support for help. So if you do the Lewis intent is help, it's going to do that. It has things for list subscriptions, logging out, logging in, and etc. And then of course it has a none. So when the intent is none, then it says, oh no, I can't handle this. I need to forward this to one of the other dialogues, or just say that I don't understand. So that's where we have this little factory that picks up any DLLs in here that has dialogues inside of it, and then goes through each one of those dialogues and say, can you handle this phrase or not? And if it can, then it picks up that dialogue, returns it here, and does a context.forward to that dialogue. Does that make sense? So if I show you here what the dialog factory looks like, it basically goes in, loads all the assemblies and the dialogues from the code, and then for each one of those it says, can you handle this? And this is what it looks like from the VM one, for example. It's just a pretty simple for now, a list of, I can handle things that say VM, virtual machine, machines, VMs, or even machine here. And if any of those is in there, then it will reply saying, yes, I can handle this, give this phrase to me, and I'll try to take care of it. Once it's done that, then it just forwards it to this VM dialog, and then it puts it through to a different Lewis model. So I have one for the root there. You see it here. It's just those two attributes with the API key and the password for that model itself. And once it forwards it to the VM one, it just puts it through a different one there as well. So I'll show you here. So in Lewis, that was the original one. You see, we were running into multiple intents. We went up to 20, and back, I don't know if it still is, but it was 20 was the limit for intents for each one of them. So we decided to split it up, and now we have this root one, we have a VM one, resource groups, and then for each one of these, we then say, this will only handle things for a virtual machine, and this will only handle things for a resource group. Let's wait for that to load. And you see here that then the VM one, all it does is handle everything to do with VMs and nothing else from the others. So this is how we're basically allowing it a team or a group of people to focus on building this, everything that has to do with VMs, and not have to worry about the rest of it. And then we built that forwarding back and forth between the root dialog and all of these, right? So for example, stop VM, it has a parameter called VM name, and that's what it needs to identify from the labels. So just like Bill showed, we have quite a lot of different ways of talking to it. Just like the one I used yesterday, tell me all of my VMs now, being pretty rude. And that just identifies list VM. So we trained it over time to just say, oh, depending on what the person says, these are the intents. And then this translates into the code here. So for example, this is the VM dialog. If you say list VMs, it'll go into the specific list VMs method here, right? And then, of course, then we talk to the, we have a separate class to just go into Azure using the Azure NuGet packages to get the list of VMs and translate that back into text that the user can read back to the bot. So that's root, VM dialog, call into Azure, and then once it's done, it says, I'm done. That's the context.done at the end here, and says, this dialog is done, go back to the root dialog and just wait for the user to say something else, right? So that's pretty much it here. Let me see if I can get it started. Oh, no. Yeah, there's something wrong here. But this, that's pretty much it from the Azure bot. A few dialogues, forwarding backwards, and then talking to Azure behind the scenes to go and actually do the commands. And that's how we expect to expand it. The other couple of things that I wanted to show you is we basically have a couple of build definitions in Visual Studio Team Services to handle the deployment of the bot. But for bots, this part of it, the continuous integration and deployment, is pretty straightforward. Because it's just a web API, right? So whichever way that you're doing CI and CD for a web API, you're just going to do it for the bot. So in this case here, it's just, because it's .NET, it's just doing a Visual Studio build of that in copying the zip file of it to the output. And then on the release side, you see I have a few environments. A couple of them are failing tests. But if I go into that release definition, the environments that I have is the first one, it deploys the bot to this beta version that we have, and that's just a web Azure app service deployment. Then we run a few tests that we have automated. So we have tests for runbooks, for VMs, and some tests that can be run in parallel. And that's all in this class here, the Azure bot.tests. So for example, for should list VMs, we're just saying list VMs and expect it to start available VMs are, and then with the list of VMs, right? So pretty simple. And we use the direct line channel. So I don't know if you remember before when I said there's all these channels, and then direct line is the one that you can use to talk straight into the bot framework. So that's what we're using here. We're using the direct line token to then talk straight to the bot and testing it. So this area of testing is a little bit more interesting if you're looking at a more DevOpsy perspective for bots itself. And then once it's tested and we're happy, then we allow it to be deployed to the production environment. Another cool thing that I like about it is that you can enable application insights to look at exceptions and tracing for your bot as well. So what I have here is for the Azure bot, we enabled application insights. And you can do it on the bot framework dashboard itself. So if you go there and configure it, you can already enable it and it'll start tracking a few things. But then, of course, because it's just a web API, you can add it to your web API as well. So here you can see it's just showing me how much is being used and the number of requests per performance. And if I drill into it a little bit more, I can even find out the dependencies that it's calling. So because I run those tests, the direct line is at the top here, and it's just using that, and apparently those are pretty slow. But then from there, all the management API for Azure, and then the conversations between all of the different interfaces that we have enabled for Skype, Slack, and etc. So I can use this to both identify exceptions that happened in my bot code, but also find out if there's something else that's causing the problems for my bot and not my code itself. So that's pretty cool as well. Since we're just deploying to Azure, it made sense to enable application insights for us to learn more about the feedback that we can get from the usage. Then finally, it's open source on GitHub. It's more of an example than a Microsoft product. So it's a sample that's there on GitHub, and most of the work, the split up into multiple things is in this add extensibility. The one with the forwarding of dialogues, that's in the add extensibility branch, but the URL is github.com/Microsoft/AzureBot to get to it, right? So if you want to check it out how we did it, then with more time, then that's the URL there. And finally, just to remind you of where to find more documents and more samples, there's botframework.com. There's a whole lot of documentation there about the bot framework. There's a really cool course on the Microsoft Virtual Academy site, aka.ms/bot course, and that's a few videos that our team did to go into more details about it. And then quite a lot of samples. Even the second one, the bot builder, that's the actual bot builder framework. Under there's a few samples as well if you poke around there. And then finally, if you're looking at cognitive services, then you saw me use it there. It's pretty easy to test it out even from the website. And that's the URL for the cognitive services. Cool. So covered quite a lot, showed a few bots, showed a grumpy bot, I explained the Azure bot. And I must have said bot a million times. Now it's your turn. If you have any questions, let me know. Yeah, that's a very common request. Yes. I don't have dates or anything, but it's very, very common. Yes. He asked about Skype for Business. Yeah. Any other questions? Pre-trained intents. So what you can do now, you can export it and import it. So that's how we went with from the Azure bot, for example, when we had everything in one, we exported it and then re-imported it into all the other new ones and just removed the ones that didn't make sense. But I don't know of a way to run it on premises, not connected to the Lua APIs itself. Yeah, so not that I know of. You can't run it offline at the moment, right, Bill? Yeah. Not yet. I've seen that request as well from a few of the Hackfests that we run, where if I don't have connectivity, but I still want to try to find out the intent of what do I do? Yeah. At the moment, it needs to be connected. Yeah. I think there's one of them that Nigel showed at the keynote yesterday where it can get repeated visitors. So it identifies the person once, and if it sees that person again, it will just recognize the same face. So I don't know exactly which one. We can find out from Nigel later on, but there's one of those APIs that will let you use that to identify the same person. Yeah. Yep. Any other questions? Yep.
On the workflow side of things, what type of work in IVR space is there for workflow and computer sciences? How do you hook up those interfaces to one another?
So how do you connect multiple interfaces? Yeah. Yeah, so I've seen it done before because your code is just web API and you're seeing all the messages that are coming in through there. That would be the place where it would then forward to your IVR API. It's just, of course, it needs to be something that you can get to from the bot framework wherever you're hosting your web API from. You would do the conversation to it back and forth from there. I've even seen examples where someone is talking to the bot from Skype, and it was forwarding all the messages to a Slack channel as well. But that's from your code in the web API. You would do the forwarding and back between those two. And then eventually you can then say, okay, let's switch over and give up on the Skype conversation and give a link to the user to go, I'll continue the conversation here with a human or with a different method. Yeah.
It's not a heavy use of context in there. So how hard is it to unit test all the bot code that was written there?
Yeah. So for unit testing, there's an example from the team itself that is a dialogue-based test or dialogue test base. So if you go into the bot builder GitHub and look for that, it will show you how you can mock the bot framework itself and just run the tests against that mock one to unit test it. Yeah, the testing that I was doing from the Azure bot, it's all functional testing, I guess, because it's already, once it's deployed to the web app, then I'm running commands against it and expecting a specific result. But for unit testing, then that other method is easier. So it's dialogue test base, I think, or dialogue base test, one of the two. Yeah. And it just mocks the bot framework for you and runs your bot against a few commands. Hey. Yeah. Yeah, so that came up at Bill's session as well. When you have multiple intents, the Lua itself, it doesn't really handle multiple intents in the same phrase. I discussed this with my coworker the other day, actually, and the way it is now, it tries to identify one intent for a phrase, And if there's more than one, or if you want to deal with it yourself, then in your code, you can get the original text that was sent by the user, and then you would split it up yourself and then send those two to Lewis to identify the intents of each. So if you want to split it by an end or some keywords, and then send those separately to Lewis, that's the way I would go about it at the moment. Yeah, until that gets added to the Lewis itself. Yeah. Hey.
Is it possible to group multiple bots together into a single one?
Um,
When you're like in a system with a single interface, I want to choose a bunch of different bots that I can interact with in that single place.
yeah. So that's the technology that some of the assistants are trying to do. So not bots themselves, but things like Cortana and Siri and others, and they are the ones that would go off and talk to multiple bots for you in the future, of course, not at the moment. But that's where it's going. I don't know of a specific interface at the moment that would allow you to combine all of these different bots into one thing, other than you writing the code yourself. So doing the backwards and forwards. There's been a few examples that I've seen where the company owns all of the bots, and you keep track of it in Azure, an Azure table service or somewhere. Keep track of this user has all of these interfaces, and this is the IDs and the conversation ID for each one of those. So if you want to forward between multiple bots for that user, you can by keeping track of that user and the connections for those. But if you don't know all of the bots, then it gets really hard. Yeah, but if you do, then yes, then you can do that by keeping the state outside of all the bots and keeping track of user, channel ID, and how to connect with that user using multiple interfaces. Yeah. All right, looks like that's us. Thank you.